Great. Thanks. Hi, everybody. My name is Ben Sautner. Thank you for joining. I'm a senior principal engineer at Comcast. And for the last 6 years, I've been part of the engineering team at Xfinity, where I've worked on the Xfinity Home Android app, which is used to control your home security system and your devices like your home lights and door locks and garage doors and home security cameras, and our Xfi app, which is used to manage your home network and your Wi-Fi. So today I want to share what we've learned about building Android apps at Comcast scale. So for those of you who are Comcast customers and you have the Xfi app on your phone today, you may have noticed that it's been recently renamed and rebranded as just Xfinity, and we now refer to it as the Xfinity app. So besides controlling your home Wi-Fi and doing things like pausing your Wi-Fi during dinner or limiting the time your Xbox can be online, you can now use the app to do many things you can do in Xfinity Home, like see your home security cameras and your security recordings, as well as do a lot of things like built-in network security to protect your home network. You can test your internet speeds. You can also do things like purchase our Wi-Fi extender pods or upgrade your modem, and the app will take you through installing and onboarding new devices into your home. So what I really want to talk today is about what goes into building an app of this size and how we're able to work productively at a very large company with hundreds of developers and a common goal of shipping this product to our customers. And we actually ship new versions of our app to production every other week. So I'm going to talk about building this app and what this app has been in production for many years. We have millions of weekly users. But today when I talk about scale, I'm talking more about scaling horizontally rather than vertically. And to explain that, when I say horizontally, I mean the diverse number of features this app provides, from home automation and protecting your Wi-Fi network, as I mentioned. So there's many apps out there. Some good examples are like Twitter and Instagram. They have very specific set of features. And these apps need to scale vertically by doing these very specific things very fast for a huge number of users. And while the Xfinity app needs to be performant for millions of users, but also produce a highly diverse number of different functionalities in one app. So as we keep adding features and as the features change, we need to work in a way that makes changes to the app easy for developers to work on, in a way to keep the apps from kind of collapsing under its own weight. So an app of this size can take something like 30 minutes to do a full build on. It can take 20 minutes to run all of our unit tests. It can take 2 hours to run our UX automation tests. So this can really be brutal for developers who want to make changes to the core of our app and our code base, or to make changes to a back-end web service without risking of breaking something. We also have like 10 or so build variants to support syndicated partners. These are other companies that use our app with their branding and companies all around the world. So today I'm going to talk about how we overcame many of the challenges that we encountered over the years. So this talk is all about communication between different stages of our development. So we use the tools of our trade as a way to communicate between teams. I'm going to try to explain that to the best of my ability, but to make sure developers are happily coding away and not spending a lot of time trying to understand how a web service worked that maybe they weren't on the team that wrote that web service, and writing client code and data models and trying to understand different parts of this machine that they might not completely understand and have to spend a lot of time learning and ramping up. So each of these dots are essentially the 6 slides in my deck I want to talk about today, and each part of our development process. So first, we build microservices. We use the open API standards to produce what's called API docs. You might also know these as Swagger docs. Open API kind of replaced the name Swagger. But if you're all familiar with Swagger, that's kind of what it is. These Swagger docs define what our microservices APIs look like and can be consumed by a code generator to produce these perfect representations of an API client with all of our retrofit models and interfaces. So platform teams hand off new versions of their web services to us by delivering that new version of the API spec that we then consume with that code generator. So I'm going to talk a bit more about that. We use GitHub templates as a way of spinning up new feature projects extremely fast. And this lets developers get to work right away and gives a way for senior engineers to build onto that template and put all the best patterns and practices that we want other developers to follow by giving them that code structure and class structure and all the different components in CI/CD that go into that template that then is used to build new feature projects. We then use that template to build Android libraries, and each one of those libraries can represent one or more features inside of our app. And that gives a way for small teams to work in a small code base, like laser focused on their feature. And I'm really excited to show you how that works for us. We then work on what we call reference apps. So this is an app that just demonstrates that one feature the team's working on. For instance, we have a camera crew dedicated to our home security cameras and recording playback and that kind of thing in motion capture. And that reference app, we have a reference app that just demonstrates and exercises the camera features, and the reference app implements that library exactly how the Xfinity app would when that goes to production. And finally, I want to talk about how we use dependency injection as a way for the reference apps to communicate their requirements back to the implementation in the Xfinity app itself. And so as you can see, again, each one of these dots represent that communication between the web service developers, the senior engineers building the templates, the engineers working on the libraries and implementing the reference apps, and then how those are then need to be implemented inside of the main Xfinity app using Dagger. So before I talk about the Android development, we need to talk about how our backend web services are being built, and that drives the data for our app. If you think about how massive our infrastructure is when it comes to the moving parts that control your home Wi-Fi versus the moving parts that control your home security cameras, and these are completely different environments, and our job is to make them into one experience. So we've experimented in the past with building monolithic web services, and there's that one API to rule them all concept. And from my experience, I recommend against that approach. And a lot of people use GraphQL and expose that to your clients. There's Hypermedia and Hatios, which I personally really don't like working with Hypermedia-based APIs, but I never felt that those were appropriate for mobile app development, maybe good for backend development. We find that building microservices based on the Open API spec make it so you can build and deploy a web service and make changes to it quickly without needing some massive cross-team communication and any risks that you're going to may take on making a change that may break some other part of your app, and how difficult those things are to track down. So we build services following these Open API specifications. These are generally REST-ish services with JSON that's going back and forth between the app and the web service. What's important here is when a brand new version of an API web service is shipped from a platform team, they also ship that API doc spec that I mentioned, which is essentially a YAML file, and that defines all the models and endpoints. So we use a tool called Open API Code Generator, which is an open source program. You can download, go search for Open API Code Generator, and you'll find it. The code generator will ingest the API spec and generate the client code needed to consume the web services. So a few things happen here. First, there's an option to this tool to run a verify routine on the YAML file. So right there, the verify tool can report errors in the spec that the team will need to go back and fix. So by tying that into your build process, when a web service developer opens a pull request to make a change to the web service that we're developing, that verify script will kick it back, put a -1 on the pull request, and say this isn't formatted correctly for the mobile teams to use, and it never gets out of the web service development shop. So by the time these specs are shipped to the mobile teams, we know it's perfect. So the platform developers are shipping the spec in that API file. And what's great about that is that we're also running this for Android and iOS development, because the code generator supports Swift and will create Swift client code. And you don't really need a lot of domain knowledge of the backend service to use it. So when this works, we get a perfect representation of the paths and the query parameters and the object models and the headers and everything you need, especially cache control headers, which I'm going to speak a little bit later on about, which is hugely important. All of this, these are perfect retrofit interfaces and libraries and data models. So say if you're an Android developer and you're being handed a web service and asked to manually read through the docs and build your own retrofit interfaces and models, this saves you just a ton of time. Really, if you're writing retrofit interfaces by hand, lift that hand off your keyboard and smack yourself, because you don't have to. That can all just be generated and you don't have to worry about it. So at this point, you get an Android library. They're giving you the first version iteration of a new web service will give you version 1.0. And then each time you make a change to that web service, a new version of the spec is shipped, a new version of the client library is built and deployed out to a Nexus repository for the client developers to consume. And the one most important takeaway from that point of my talk is a story I like to tell about back in the day at Xfinity Home, where we had a field in a JSON response from an API that told us if a light in your home was on or off based on a Boolean flag, and that Boolean flag's name was called is on, and it would be true or false. And we consumed that, and then we wrote our own client code. We were doing this by hand, and we had some code that was looking for a field that was called is on. So then a new version of that API was released, and somebody just thought it'd be a good deed of the day to rename that to just say on in the field. So the field was renamed on, and in the JSON response, we instead of getting is on equals true, we got on equals true, and that caused our apps to crash because the code that was looking for that is on field, instead of getting a true or false, it got a null because it didn't exist. And we got a null pointer exception and the app crashed. And unfortunately, we caught this in staging. But what this process does for you is it pushes bugs like that can be introduced by handwriting client code to compile time. So when you import the new version of the library, you would build your app and you would get a compile time error saying, field that the field doesn't exist. You get a red squiggly. So that used to be something you would catch at runtime, and in the worst case scenario, that's something you could catch at runtime while your product's in the hand of your customer. So taking any of those issues where an API change didn't get caught, the client code didn't get updated, and you end up with app crashes, pushing all this down to compile time and shipping these new versions and just making that part of your work extremely valuable. Okay, just a few dots there. So here's an example of running CodeGen against an API doc to build a library. I want to kind of walk through this command as an example of building a Android library based on a web service. So just kind of reading from the Java command here that you would run against this Open API client generator. You can see that -i is telling it where the API doc for the web service exists, that we want the language to be generated as Java, bunch of little package names and where we want things to live, that we want our library to be generated using Retrofit 2 and use Java 8, and use RxJava, what our package names should be, where we want our models to be. And that gives us a library that we want. And so what I love about this is that the API teams have no idea how Android works in a lot of ways. So they've never heard of retrofit or JSON or things that only the Android and iOS developers would know about. So when we give them this script to run against their API that generates a library that's exactly how we want it to look, that's again another step in the communication where we're using our code and our code development process to communicate requirements between teams without this having to be like an explanation in an email when they just come back and say, what's Kotlin? I never heard of that, because they're Go developers building a web service. So feel free to check out the OpenAI generator. I added a little bit of a list here to different things that it can generate. But it's importantly too. So if you look at the code that I put at the bottom, it's just a sample of a retrofit interface that generates a little Rx Java observable. I know a lot of people are working right now on the Kotlin generator that's going to return a coroutine, and that's still kind of a little green. But we're really looking forward to that existing. But you can see that this is generated code that I didn't have to write. It has the headers, the body, and everything else I need to use this API. Okay, so now we're on the next step, which is the next ball in the bouncing ball we're following here, which is we've built a bunch of microservices. We've generated client libraries based on them. We've handed them off to the client developers, and now they're going to start working on a library. But we want we call that the implementation library. So we use this using GitHub templates, and this is where all of our most senior engineers work together to put an empty Android library project in our GitHub. This has all the patterns and best practices baked into it. Sample unit tests, sample class structure, code patterns, examples of things, how we want new developers who are just being onboarded to how we want their code to look. So you still haven't had to touch the Xfinity app's code base, and our template project has also built into what we call a reference app, which is a template for everything you need to get going with, and it has things in it that you would need to build your feature, like our login flow, and so the reference app knows how to log in with credentials and give you authenticated tokens and things like that, and all the Gradle dependencies that the Xfinity app uses. So I just remember, this isn't a fork of a template library. There's an option in GitHub, if you didn't know about it, to turn a project into a template that can be used to create a brand new GitHub repo. So when teams use this template, everything they need to get going is right there, and you're ready to hit the play button on your Android Studio and get your empty app that you can work in. And we're very confident that all the code you put into your library is going to work just fine when you go to the actual Xfinity app's main code base and add your library to its Gradle. And then and any changes you need to make to the app to load your fragments and your views and do whatever your feature does. So at this point, the team is working on that implementation library, and you might be importing one or more client libraries. So if you're talking, your implementation library might use 6 or 7 different microservices. So you end up with 100 or more microservices that you need to talk to. Those get boiled down into maybe like 15 to 20 implementation library projects that all have their own reference apps. So by this design, it means we can isolate code to a specific feature and prevent feature-specific code from leaking into other features of the app. And this means that if we build a next-generation camera library, it's just a matter of changing the library referenced in the main app. It doesn't require major surgery to go into the main code base and change everything around. So bumping a version in your Gradle to use a new feature, or changing the library referencing, versus going very deeply into your code, trying to find out maybe somebody referenced a class that you were using for something else, and now it's dependent on it, and things get all tangled up. So this also means that since a feature squad is working in this somewhat isolated code base, when we see a spike in app crashes or bug reports, or SonarQube tells us that coverage is really down or some bugs are detected, it's real easy for us to know what team to send those issues to. Because if you have a gigantic code base and you have an app crash it's really hard to tell who owns that app crash and what team and squad needs to pick up that defect and fix it. Also, on the flip side of that, it makes it really easy for us to see what teams are writing the really high quality code, and which teams are making have super high code coverage, and what libraries are in really good shape on our lints and SonarQube reports. And that gives us a great opportunity to say, hey, maybe we should switch up developers for teams that are struggling with teams that are doing great, and educate everybody, and we all become great developers. So if a different crew needs data that's in a service built in from a different feature, that's no problem. We can just import the service client library and share those among the two different projects. you can really take advantage of cache control during this by doing this. So if you have a web service client library and it asks that web service for some data, and another project completely a different group needs the same data, but you're both sharing the same OKHTTP client, you're using the same retrofit libraries. If both of your features make the same API call and get and there's a cache control header in that response, the first call might make a web service call, and the second one might just get cache data. And there's really no need for you to do any more work than to optimize your app that way. You're going to get that free cache data from other parts of the app that are making identical web service calls. This is also a way for where developers come. Everybody here is going to come back running from this conference and with a lot of excitement about new things they wanted to do and new toolings and new things that Google came out with that we all want to play with. And so this really helps you not get locked into any one tool set. Developers love to chase that shiny new tool and do new tricks that we've learned. And if you have a large monolithic app, it's really hard to change patterns and to adopt new technologies. But this does free you up. I mean, we provide a lot of guidance and leadership when developers want to try something new. But there's very little reason why you can't build a new library and adopt some new pattern you think is better than what we've been doing. And if that really works extremely well for us, other teams can pick up the same patterns, and we can get together and say, hey, everybody, we should change the way we're doing something. And it's kind of easy to do that. In a monolithic app, you can't do that. So we have engineers today who are experimenting with new versions, a new way to structure our Dagger graphs. We have and we're encouraging to do that. And we can say, hey, if this isn't working for us, we can roll it back. We can go back to the old way. I really want to use Jetpack Compose. Been waiting for a long time to not have to build UI using XML. So it would be really hard in an app that's been under development for 3 or 4 years to switch a way of building UI and not having that be a confusing thing for other developers who might not know. Even new developers coming out of college might not know what's the right way. I see 2 ways we're building UI. So we could build a feature using Jetpack Compose and be very isolated and safe and do it without any real risk to our development process. Lastly on this, often in a big company, our business leaders want to try some new technology or new third-party library. A good example for this are analytics, where third-party companies who want us to use their analytics tools to kind of understand, how our apps are functioning and do what's doing well and what's not doing well. And you never want to go back and say we can't do that because our app's so locked into some other technology, and it would take major surgery to remove that. But by following this pattern, we can treat third-party libraries exactly like we treat our web service libraries, and have that same power to be able to easily swap things out. And I love being able to go back to our leadership and say, we can create a sandbox. We can create a means for you to try out some new product or third-party software in our app, and we can mitigate that risk and not freak out about it. Great. So we're moving right along here. So the last step of getting your feature library. So now you're a developer on the Xfinity team. You've created a new feature. You have your reference tab. It's passing QA. Everything's working great. The next thing you want to do is get it into the actual Xfinity app. So we use Dagger very extensively. We're trying to move to Hilt, where we have a couple challenges there. Hilt does not like this structure because it needs the application class to work for the annotation processor. So we actually want to kind of pop into the Hilt GitHub and see if we can contribute to that to make Hilt work in this structure. But we're using Dagger right now for all of our dependency injection. And so on the 2 bits of code I have here, the code on the left, at least on my left, the component class, that's an example of a feature libraries Dagger builder. And if you're not familiar with some of these annotations, I'm excited to educate you about them. We use the component builder pattern and those binds instance annotations. So the Dagger annotation processor will turn everything that library requires into components in the Dagger builder. So when you release a new version of your library, your feature library, you might add some new binds instances fields to this builder, and right back to that original point of this is a way to communicate requirements to the next stage of this development process. Where if I add a new binds instance for a string that I need or something like that, it gets added to the builder, and so when the new version of your feature gets added to the Xfinity app and you bump that version in your Gradle file, you're going to get a compile time error here because you're missing a required component. So that's the way of me telling the next stage, I have some new additional requirements that can all now be called at compile time. And then we add them. So on the panel to the right, this is an actual injection, some fictitious feature control class that requires a few things like the application context. So if you notice that there's a field called TTL, time to live, and it's annotated with a qualifier called TTL as a qualifier interface. And throughout our entire Dagger graph, any other long value that gets annotated with that TTL, this is just a random example of a time to live value being set to 0 in the app, will get that value assigned to it. So if all throughout your Dagger graph you need that value injected into different things, using qualifiers throughout Dagger, it's just like the one qualifier you might be most familiar with is the named qualifier, but you're always able to write your own and assign those values all throughout your Dagger graphs. There's a huge amount of power in that. And again, that last need for a feature team to be able to say to the implementation of their library in the Xfinity app, here are some new requirements that I need, like a new endpoint or a new thing I need to talk to. And the big part of this is the HTTP client injection, where we inject we create the OK HTTP client we use in the main app and then inject it into the libraries. So they're all sharing the same OK HTTP client, and we have some variations for different needs. Not every OK HTTP client can do everything, so we have some specific ones for different libraries. But the OK HTTP client contains the HTTP cache, which means that if I inject that client into 10 different libraries, they all happen to need the same data. There's no need for like a shared data store or to pass data around back and forth. You can really rely on that OK HTTP client to give you a cached value when necessary. That gives a lot of power to the API teams, web service teams, to communicate to the clients how long to keep data and when data should expire. I think I always like to challenge any engineer who says they need to store something in the app as to that should always be an exception. It's something you need maybe with a really long time to live, but you can set a cache control header that says this value should be cached on your app for a year and you're fine. So you always would challenge, why are we building a data store? Why are we sharing data and not just relying on the HTTP cache control? And there are exceptions to those rules, totally fine to do that. But that's always the first question that I like to ask when looking at a new feature. Great, so we're at 30 minutes. I'm glad we're right where we want to be. So this is the end of the slide, this last slide. It's some of the lessons learned, things I want to talk about. Some of these are personal opinions about how to build an app that can not only scale horizontally with more users and vertically with more users and horizontally with more diverse features, but also you're building an app that has the potential to grow very large. So that's when you as a developer, you're out there building an app for your business and your career, and your app is going to grow, and you're going to need more talented developers to join your organization. Your org's going to grow, and your app's going to have more and more moving parts and changes. So over this time, new exciting tools and technology will become available. We want your app to be able to migrate and adopt these new tools and really avoid being locked into any one design pattern. Your app's going to mature and need to have more features, replaced with new versions of those features. And you don't want that to be a major time-consuming or require a major surgery or refactoring in your code base. So the most important takeaways I'd like to leave you all with today are avoid those monolithic app web services and apps that become unmanageable and tangled, super hard for new devs to ramp up in, and it makes it really hard to retain talented developers when they're having a frustrated environment where they don't want to work in some 500,000 line Android app. You want to make it okay for developers to try new things. You need to keep a careful eye on those things. But right now, we're trying new ways to structure as I said, I was trying new ways to structure our diagraph. We all want to try Jetpack Compose. And this really this kind of architecture really mitigates those risks. And the fact that we can move to Jetpack Compose, a humongous app with tons of moving parts, and to be able to jump on this new exciting way of building UIs means that we're going to attract talented developers who want to work with those technologies. And when we say what if we were saying we were so locked into RxJava that we couldn't move to coroutines? A lot of people at this conference want to do coroutines, so it allows you, kind of frees you up from that. You make it okay for your business to experiment and try to always be cache control first with your data. And the very last point I want to make is about package structure, something I'm pretty passionate, maybe overly passionate about. But when you're building an app, and if you have, and you know who you are, if you have an app with a package called fragments, and that package contains all your fragments, and you have another package called models, and that contains all your models, that design, that way of building an app that has more than 10 or 15 different features or 15 different fragments won't scale. And so you should never group your code by function. So just because all of the code in that package is a fragment, don't put them all in a package called fragment. You should have, what I like to say is your package structure should tell a story about the code they contain. So if I'm looking at the way our code is organized, and we have com.comcast.xfinity. Whatever, and then there's a feature package that has in it a bunch of different features in there. There's a camera package, and everything about cameras is in that package structure, and that there might be a fragments package in there, but they're all camera fragments, or they're models. They're all camera models, and so if you have a project that has 100 classes and they're all in the same package because they're all the same thing, they're all data classes or something like that, break those up into features. That's going to allow you to pluck those features out of your main code base and put them into libraries and kind of get things moving a little bit faster. So that's my good deed for the day, is spreading that message. So yeah, that's my presentation. I'm now super excited for my 5 awkward seconds while I wait for questions. But, oh no, they're right here. Okay, great. That's great. I got lucky. How do you handle API versioning, especially I got to move this window. It's blocking the question. Especially to continue support of older versions of the app? Great question. API versioning is super hard. And so typically, we always introduce non-breaking changes into our web services. They become somewhat immutable, and we might create a new endpoint and point the new a new release of the app to that endpoint that has something different in it. We do at Xfinity Home have a challenge where we have really old versions of our app out in the wild. And we try really hard to make sure that they keep working. But I'm amazed sometimes when I look at our logs and I see a version of the app that's like 5 years old, and I'm like, "Who are you? Why would you refuse to upgrade to our latest version?" Even we support we generally support Android versions going back pretty far beyond what Google does. So like we support Min SDK 24. We just want to. So We do have kind of a rolling upgrade to suggest users upgrade new versions of the app. And then finally, last resort, forced upgrade functionality, where you'll load the app and it'll say, you got to upgrade because this version's not going to work anymore. How do you limit the unnecessary pieces from code gen? Does Comcast maintain those code gens? Great questions. Code gen will also generate for you a big, giant, fat OAuth client. We ignore those chunks of code that we don't need, and we let ProGuard filter them out. And so we don't care. And the next step, I think, for us is that we'd like to contribute more to the open the CodeGen project and put in some flags and features to say don't give us this weird Oracle OAuth client. But again, there is unused. Whenever you're doing the generated code, you get some junk you don't need, and we just let ProGuard filter those out. How do you handle theming styling in your libraries for different third-party partners and apps that require a customized look and feel? We do limit what our partners can ask for as far as different styles. So we're saying, hey, if the button's blue for everybody. But we do put a lot of our different styles and colors and features and how things look are also in a library. So we bump versions of that library, and the color blue changes for everybody to a different shade of blue. We even have a large UX department that gives us those changes, and those get propagated out to our entire product line. When code organized by features, how to package common shared functions which are support multiple features. Awesome. We have, it's libraries all the way down. We have a Commons, Xfinity Commons library, which have the really, really boilerplate shared code that are like utility code and things like that. And then all of all the different library projects import those. We do little scans at our GitHub, find ones that need new versions. And so we just lift those up. So even if there's a base class that all the fragments need to extend, those come from a Commons UI library. And it's there's that inversion of control there that we want to make sure that we're injecting things into our classes from different libraries. Do you think that having Dagger component for each feature is over-engineering? We have it here, and devs complain on the boilerplate. So we try to protect devs as much as possible from that. And what's interesting is we talk about this all the time. And there's an engineer listening right now I know is trying to reduce the number of Dagger components we have. So we're that's a question that we kind of talk about over time. I don't really think I have an answer for it. So except that it's just definitely one of the challenges we have on a regular basis. But great. I just want to thank everybody so much. Please check out Yesh's talk next, who is a fellow coworker of mine.